Hello, hello. Today we're going to be talking about my favorite part of biological anthropology, which is forensic anthropology, as well as a little bit about human variation. So to start out, what is forensic anthropology? It is a specific subfield in biological anthropology that involves applying skeletal analysis and other techniques to solve criminal cases. Now, oftentimes, forensic anthropologists will work with law enforcement agencies to help identify individual remains, as well as to help understand the circumstances surrounding their death, which can then help to bring closure to the families as well as solve crimes. Now, forensic anthropologists are not always going to just be working on the bones or the remains themselves. Sometimes they are also helping to create genealogical profiles, as well as choosing which bones to send for DNA and other types of testing. So what can we determine through forensic anthropology? First, are the remains even human? It's not uncommon for someone, just, a normal everyday citizen, to bring in bones to, oftentimes to labs within universities to ask biological anthropologists if they found a human bone or not. Most of the time it is not, it is an animal bone. We can also determine things like MNI. This stands for the minimum number of individuals. And essentially, you were just determining the least amount of individuals that can be identified from a set of remains. The reason that we don't do the maximum number is because it is really hard to tell if every bone belongs to one individual. You might have bones, especially if it's from an area that's been kind of tampered with, or if it's from like a collective grave site. It's really hard to tell that this bone specifically belongs to this individual or not, but you can always tell if you have 2 skulls or 4 patella that these are going to belong to at least 2 individuals. You can also determine things like age estimation, sex estimation. Notice I've said sex estimation, not gender estimation. Sex is a biological factor. It is considered to be very binary, male, female. Of course, we've talked about previously that there are people that are born intersex, and that can be a little bit harder to determine, but the scales that we use for sex estimation do allow for a little bit of ambiguity there in the middle if you are not completely certain. We can also do stature estimation, so how tall somebody might be, as well as group affiliation, also commonly considered ancestry estimation. Now, with all of these estimations, they are just that, estimations. They are not perfect, they are not 100%, especially with things like group affiliation. And so we typically do not ever want to say that someone is, definitively a African American or definitively Hispanic or anything like that. And part of this is because a lot of the ways that we label different sets of humans are actually just very social constructs. They don't reflect that well in the skeleton itself. And a lot of the data sets that we use to determine these things are pretty outdated. They aren't using sample sizes that are really reflective of people as a whole. As well as in today's world, we have a lot of admixture. So obviously there are people that have very mixed ancestries. And so it's really hard to then say that they are one ancestry or another based off of their skeletal remains. There is also just a ton of variation within humans, even with our skeletal structures. So it wouldn't be completely accurate to say that we can tell that 100%. Same with stature estimation, actually. This can vary a lot. And a lot of our samples that we use to determine these things, again, are a little bit dated. And just really need to be updated because we as humans, as a whole, are actually getting taller over time. Moving on, though, we can also determine some things like time since death based off of decomposition rates. This isn't always going to be that this person has been dead for 6 months. A lot of times this is going to be based off of injuries and other healing that we notice on the body. So whether it is antemortem, postmortem, or perimortem, this kind of coincides with this trauma. Antemortem means that it happened before death, so it's had some kind of chance to heal, and you can typically see that fairly easily because bone remodels in a very specific way. Perimortem means that it's at or near the time of death, so it might have happened slightly before death, but the bone hasn't had a chance to completely remodel. And then postmortem is anything that occurred after death. We can also determine manner of death. However, this is different from cause of death. Forensic anthropologists do not determine cause of death. That must be determined by a medical doctor or by someone that is actually doing like a physical autopsy on the remains and has that legal authority. Forensic anthropologists are not doing that. We can determine manner of death in the fact that we can see that this injury on the person is obviously, a bullet wound, or maybe that it's blunt force trauma that hasn't healed. So then we can, in our report, suggest that this might be the manner of death, but we do not ever say that it is the cause of death. Now, are the remains human? It might sound like this should be easier to tell, but for somebody that's not experienced, it can be very hard. So if you look at this image below, these hands look very similar. If someone isn't trained in being able to tell what is human remains versus faunal remains, or otherwise known as animal remains, they might confuse this bear claw with a human hand. For the record, the human hand is actually the one on the left side, whereas the bear claw is the one on the right side. This minimum number of individuals, you're just going to determine by looking at elements that repeat more times than they should. You can also do this by looking at the side of these elements. So if you have 2 left femurs, then obviously your MNI needs to be 2 because humans do not naturally have 2 left femurs. So there are different ways to collect data for estimation and observation. So there are macromorphoscopic and morphological traits, and these are going to be much more qualitative. They're less precise and much more subjective because it's actually based on your opinion. So it's subject to a lot more observer error, but this typically improves with experience. So somebody that has a lot of experience with forensic anthropology and working on remains might actually be more accurate using macromorphoscopic traits rather than craniometrics. And these are going to be traits that you can judge using your senses of sight and touch. And it's typically going to be used for age, group affiliation, and sex estimations. It cannot be used for stature. There is just no way to do that. I mean, you can make a very broad assessment that this person must have been pretty tall because the femur is pretty long, but you cannot make an actual assessment that this person is going to be 5'6" or 4'11" or whatever based off of macromorphoscopic traits. Moving on, we have craniometrics and metrics. These are much more quantitative and they're more precise because they are less subjective. So these are going to be traits that are measured using things like sliding calipers, spreading calipers, calipers, and osteometric boards. So it is data that you are actually writing down in the form of numbers. Oftentimes, it will then be put into computer programs like Fordisk. And these are going to be used for things like stature, of course, group affiliation, and then also sex estimation. It cannot be used for age, though, because the areas of the skull that we look at for age, there really is no way to measure that with a tool. So for age estimation, there are a couple different techniques. You can look at dentition. This is more commonly used in adolescent remains because it's a lot easier to tell roughly what age they are based off of which baby teeth they have versus adult teeth. And by the way, baby teeth, whenever we are discussing them in a forensic context, are actually considered deciduous teeth. You can also look at things like epiphyseal closures, and these are the areas at the end of all of your long bones that are actually not fused until certain ages. So if you can tell that something is not fully fused, then you know that they are going to be younger. And these typically will fuse more in your kind of mid-20s. You can also look at suture closure to determine age. Suture closure in this instance is always done on the skull. You can see here we have these little squiggly lines on the skull. These are sutures. We have names for different ones depending on which area of the skull that they are on. And they start to fuse at a somewhat predictable rate. However, each one fuses at a different rate. Based off of that, we can determine how old someone is roughly. We generally never want to say a very specific age, like this person was definitely 45, unless we have some kind of medical records to back that up. Because being too specific with your estimations can actually hinder identification. When you are trying to cross-reference a case with like missing persons and other police documents, being too specific can make that harder. So instead, we will typically say that this person was likely, 30 to something, give or take a couple years. But we score this by looking at our closures. We're looking at our sutures, and we use a scale from 0 to 3. So if it is a 0, it is open. That means that it is not started to fuse at all. A lot of people like to say that, if you put water in it and it would slowly drip out, then that means it's open. A 1 means that there is minimal closure, so it's going to be less than 50% fused. A 2 is significant closure or more than 50% fused. And then a 3 is obliterated. So if you're at a 3, that means that you really can't see the suture at all. It is so fused together that it kind of disappears. You can also use the pubic symphysis, which is on your os coxo or your pelvic bones, to determine age. There are a couple of different methods for determining age with the pelvis. Here you can see one of them, but really what you were looking at is the billowing, which are these little kind of dips, these little wave-looking things, as well as a loss of definition. If you see something that looks more smooth, if it's kind of got an elevated rim around the edge, as well as just like a general breakdown of bone growth, those are all kind of indicators that something is older. So the more billowing that you see, like these really rigid looking ones on the left-hand side, these are going to be younger. As you get older, your bone kind of remodels as you use your legs and things rub together. When someone gets a lot older, or sometimes due to certain medical issues, like arthritis, then we will actually see some kind of growth at the very edges. But again, none of this is a perfect science, and humans have a lot of variation, which is why we will tend to do suture closure. If we know that it's an adult, we will often do suture closure. We will do epiphyseal closure, and then also age estimation through the pubic symphysis. That way we are kind of double checking and we're getting a more rounded idea of how old this person might have been. We also have sex estimation. There is a couple different methods for this as well, but this method that you see right here is the most common. And these are going to be non-metric observations, so macromorphoscopic. And it's going to be based off of these traits here. So we have the nuchal crest. This is just a little bump kind of at the back of your head, located near the bottom. We have mastoid processes. These are right underneath where your ear canal actually is. Supraorbital margin, this is actually your eye orbitals, so your eye sockets, how sharp they feel. The glabella is right in between your eyes, right above your actual nose. And then your mental eminence, which is the very end point of your jaw. And we score these from 1 to 5, with 1 being little to no projection, otherwise known as gracile, so that's going to be more common in females. And then 5, where it's a very prominent projection, otherwise known as more robust, which is more common in males. You can see here we also have this kind of 3, which is why I said earlier that we do have a range. So if something is more ambiguous and you can't really tell, then you're going to score more 3s. Now, this can be deceiving because you can have a skull that is like an older woman that sometimes will look more masculine just because of age. You can also have a younger male that looks more feminine because they haven't had as much time for testosterone to really develop those stronger, more robust features. So when you're looking at these with your nuchal crest, you're just seeing kind of how large that is, how far does it extend out. With the mastoid processes, you are looking at how wide, but also how long they are. If they are longer and wider, that tends to be more of a masculine trait. Again, with the supraorbital margin, you are looking at how sharp it is. So my professor in undergrad always told us that if it is sharp, like the end of a mechanical pencil, then it is more likely to be female. If it is blunt, like the rounded, end of a normal, normal pencil that you can sharpen, kind of like how you would hold that, then that is more masculine. And there is a range of this, and it is very dependent on how much experience you have on what you're going to rate it. We also have the glabella. This is going to, again, be how far this kind of sticks out, although oftentimes we will actually feel that to determine more. And then your mental eminence, the easiest way to tell this, which unfortunately you guys cannot do since you are not in person, is actually to hold your fingers at that edge of the mandible and see how wide the V that it makes is. It's kind of upside down V there. You can also tell through some other characteristics, like if there is some gonial flaring of the mandible or the jaw, as well as the angle of the rami of the jaw, but we won't really get into all of that. That's a little bit more advanced. And what you do is you actually, because you score each of these traits individually, so you ignore what you found on the other ones and you just focus on the one that you were scoring at the time. That way you are not kind of making any assumptions that create bias in your estimation. And then at the end, you take those scores and you find the average. So you add them all up, you divide them by 5. If your average score was a 4, then you'd say that this is likely to be a male. If your average score was a 1 or a 2, you could say that this was more likely to be a female. Again, you can also do sex estimation with the pelvis. This is going to be based on things like the shape of the pelvis. Typically, if they are wider and shorter, it is more likely to be female, versus long and narrow, it's more likely to be male. As well as the coccyx, and the coccyx is actually kind of like your butt bone. If this is straighter, it's more often going to be a female, versus if it is more curved inward, then it is more likely to be a male. And then also the subpubic angle, which is this little triangle that you can see at the bottom of each of these. If it's more narrow, then it is more likely to be a male. And if it's wider, it's more likely to be a female. So if it's more of a V shape when you hold both parts of the pelvis together, then it is more likely to be male, versus a U or a wider shape is more female. And you might be wondering why this is the way that this is, but it is actually all because of childbirth. If we as women had very curved coccyx, or very long and narrow pelvises, or that very narrow subpubic angle, it would be much harder to give birth. We can look even further at individual parts of the pelvis. So the os coxa is the pelvis, by the way. 2 of them is os coxae. 2 os coxae make your pelvic bone, along with the coccyx there in between. But 1 is just an os coxa, and you can look at just 1 to kind of also help determine sex, which is helpful because you don't always have a full skeleton to do these estimations with. So first, you can look at the sciatic notch. You can see it with this little arrow, it's this little curve. If it is wider and more open, so kind of more of a U or like a parabola shape, it's more likely to be female. If it is narrow and kind of like candy cane shaped, it's more likely to be male. We can also look at the preauricular sulcus, which is actually very helpful. If there is a preauricular sulcus, then it is more likely to be female. If there is none, then it's more likely to be male. However, this can be kind of tricky because of how the os coxa wears. If you are not used to looking at remains, then you might mistake just the wear on that for an actual preauricular sulcus. All right, now we are going to kind of move on to areas of the skeleton. So whenever you look at the lab for number 7, you are actually going to be doing kind of a mock forensic case report. Now, it is a much more simplified case since you guys don't get to actually see it in person and you don't have a lot of background in this. But I think you guys will still find it pretty interesting, although it is a little harder than some of the other labs. So you can watch this video, which goes over all of the anatomy of the skeleton, or you can actually just scroll through and it will tell you a little bit more about it. But you can see here we have the cranium, or the skull, and we have this frontal bone here. The parietal are going to be each of the side bones there. The occipital is there at the back. The temporal is where kind of the end of your arches, like, you know, your cheekbones, as well as where your auditory meatus or your eardrum is. You can see right here too, that is the mastoid process. These little ones in here are the sphenoid bones. They're a little hard to see, but they're also an ethmoid bone. It kind of sits into your nasal and then also attaches in your eye socket. Then we have your nasal bone, which is actually only this little part right above your nose. These zygomatic bones are the end of that kind of cheekbone area and also kind of moving up towards the eye socket. The maxilla is this top portion of the skull. And typically when we talk about a maxilla, we're just talking about this top area here in relation to teeth. So you have maxillary teeth and mandibular teeth. The mandible, of course, is your jaw. This is the ramus that I was talking about earlier. The angle of that can sometimes tell you or clue you in a little bit about somebody's sex. Then we have the spine, and it's made up of 7 cervical vertebrae, 12 thoracic vertebrae, 5 lumbar vertebrae, and then your sacrum and your coccyx. And your C1 is actually called an atlas. It looks very different from the rest of your vertebrae, so typically it's pretty easy to tell, as well as your C2, which is called your axis. Now, your cervical vertebrae are a little bit easier to tell most of the time because they will have, I don't think it's going to show it here, but they do have 2 little holes on each side that we don't see as much within our thoracic and our lumbar vertebrae. Sometimes it can get a little bit confusing between like C7 and T1 or T12 and L1 because they are a little bit more transitional. Now, your thoracic vertebrae, you can always tell as long as you have the whole vertebrae, whether it's thoracic or lumbar, because your lumbar vertebrae from this side profile kind of look like a moose face, and your thoracic kind of look like a giraffe. And I will show you what I mean by that. It is the easiest way to tell them apart, and it sticks with you more. All right, so here we have the cervical vertebrae. You can see there's a little hole there. There's one on the other side as well. Our thoracic from the side kind of looks like a giraffe. There's the nose. There's the little, I'm not really sure what they're called, the little spikes on their head. And then your lumbar kind of looks more like a moose. Moving forward, here is that sacrum that we talked about. And your coccyx is actually just your tailbone. Now, it does not start to fuse to the sacrum until later in life, so it is uncommon to get remains without a coccyx available. Because they are smaller, they're easier to lose. It's easier for animals to kind of drag those off if they have access to remains. Here we have the upper portion of your body. So your clavicles or your collarbones, we have 2 of these. We have your scapula, which is kind of that shoulder blade. Your sternum is that spot that is in between, and it kind of helps attach all of your ribs. Although, unless you are older and the cartilage between your ribs and your sternum has started to ossify or started to kind of become bone itself, typically your ribs are not actually attached to the sternum in a permanent way. There's just cartilage kind of connecting them. Here we have your humerus, which does include your shoulder bone. There is a little ball joint there that kind of connects to the scapula. Then we have the radius and the ulna, which, interestingly enough, they do not lay flat whenever you move your arm. When you move your arm or twist it, they actually cross over each other in a unique way that no other bones in the human body do. Moving on to the hand, there are 8 carpal bones that make up your wrist. Now, I'm not going to go through all of the different carpal bones for you, just because that's a little bit more advanced than what you need to know for the lab. Then for your fingers, we start with metacarpals. These are actually the ones that make up the area in your palm. Then we have proximal phalanx or phalanges. Now, your thumb does not have a middle phalange, but your other 4 fingers do. And then all fingers have a distal phalange, which is this little end cap. Your feet are made up of pretty well the exact same setup, except for instead of carpals, we call them tarsals. Here is this kind of costal cartilage that I was telling you about that connects the ribs. There is also a xiphoid process that connects to the sternum here. Typically, unless that's fused, you also won't find that in remains. And then until you are more middle-aged or older, a lot of times your manubrium, which is the top part of your sternum here that connects to your clavicles, will not be fused with the sternum, so that might be in 2 pieces, or you might only have the sternal body rather than the entire thing. Your ribs, your last 2, your 11th and your 12th, are considered floating ribs because they don't attach to the sternum. Again, we have our sacrum here in between. And then we have our os coxa, and we do actually break those down into more specific parts of the os coxa, but you guys don't need to do that for the lab. Moving on to our legs, we have our hip joints there with the little ball point of the femur. The femur is pretty identifiable. It is one of the longest and largest bones in the human body. Then we have the patella, that is actually your kneecap. Patellas are fun because if you actually have them in person, it's easy to tell which side they are from, because if you set them on a table, they will actually drop down and lean to whichever side they are from. And then we have the tibia and the fibula. Before we get down to our feet, which again, we have tarsals here, metatarsals, and then all of our phalanges, so proximal, middle, and distal. And that is it. That's all we have for the bones of the skeleton. Sometimes there will also be something called a sesamoid bone, which are these little tiny round bones sometimes that you will see with hand and feet. They're just extra bones. Sometimes they develop kind of within the muscle attachments in your feet and your hands. It's not really that concerning. It's not like the most common, which is why we don't say that that's normal to have, but it's also not uncommon. I'd say about half of the cases that I've ever worked on have at least one sesamoid bone. And technically, your patella is actually a sesamoid bone as well. Although everybody does tend to have 2 patella. So if we move into these forensic charts and example case report for your guys' lab, you can see that we have age estimation, which was typically done first. You do that before you do sex estimation. And we are using the Mendel and Lovejoy method. Now I have provided some images here to help you guys tell whether it is open versus obliterated. So this A is open, B is your less than 50% closure. C is more than 50% closure. You can see it's starting to get harder to see, but there is still some definition of the suture. And then D is when it is considered completely obliterated. Now you might see a couple little like pock spots here where the suture was. And in some methods, that wouldn't be considered completely obliterated, but with Mindel and Lovejoy, it is. And then right here, you can see all the different points that we have to look at to be able to determine age from suture closure. Some of these will be kind of hard to tell with the pictures that you guys have been provided. There's just really no way to get like great photos of a lot of this. This is something that you kind of have to do in person to learn. But just do your best. Now, with this score, you are going to add all of them up, and you're going to use this chart here to determine age. So you're going to find your total number for all of the scores that you've given your sutures. So these top 1 through 7 are your ectocranial vault sutures. And then these bottom ones are your lateral anterior sutures. And 6 and 7 are used for both. But we have a vault system here and your lateral anterior. So you're going to use these top 1 through 7 for your vault system. You're going to add up all of your scores for it. So let's say you did all of them as 3s, then your score is going to be 21. Now, if we look over here, there's not a lot of information for this because it gets older, it gets a little bit harder to tell. So instead of just saying that there is no information, you're going to use the 19 through 20 and just say that this person is likely older than 51 years of age. It is better to give a range, however. So what you want to do with that, let's say you got a score of 19 to 20. You are going to take that 51.5, which is your average age based off of your suture score, and you are going to add the 12.6, which is going to give you 64.1. You can just round that to 64 as your highest age. And then you're going to take that 51.5 and subtract 12.6 from it to get 38.9 or 39. And then you're just going to say that this person is likely 39 through 54, or sorry, 64, because this 12.6 is your standard deviation. So you're just going to plus or minus it from that 51.5. Now you'll also do the same thing for your lateral anterior scores. So you're going to find those, find the total on your composite score over here, find what the mean age for that score is, and then add and subtract the standard deviation for it to find your range. It is better to give a range. Remember, we don't want to be too specific because that can actually make it harder to identify remains. And then you're going to do sex estimation based off of the Buekstra and Ubelecker, which is the one that we discussed in the lecture. So you're going to look at the nuchal crest, the mastoid process, the supraorbital margin, the glabella, and then the mental eminence. And again, you're just going to add these up, all 5 of your scores that you have, and then divide them by 5 to find that mean. Whatever it ends up being closer to is going to be what you say that the individual is most likely to be. Now, if it is all 3s, then you will say that sex is unable to be determined. If you have more experience, then you can normally kind of justify an assumption of sex that you have based off of other characteristics experience. So if you get threes, just tell me that it's unable to be determined, and then tell me which traits appear more masculine and which ones appear more feminine. Because if you've got, and that does happen, by the way, you might have somebody that is a biological female but has larger mastoid processes or a larger glabella. So then you might have a couple scores that are ones and a couple that are five, and then it kind of evens out to be a three. But then we typically would look at the os coxa and determine from there if it is more likely to be a biological female. Now here I do have an example case report for you guys. It is set up that you can just plug and play. So anything that is bolded, you guys can just replace with your information. So you can replace the observer as your name, keep all of this the same, do the case number that is provided for you guys with the forensic material, which I'm not going to show on here for ethical concerns. The date that you have done this on, you guys will need to replace this. I just forgot to bold it. And then you will have an identification summary. So you're going to collect all your data. You will give an inventory. It doesn't need to be incredibly specific. Tell me if something is right or left, which, by the way, the images that you are going to see, you need to do the opposite of what you think the side is because you are looking at it. So what is left on the photo for you is actually the right side of those remains, and vice versa. But you're just going to tell me how many of each of these is present. For the foot, or for the feet and the hands, I don't need you to count all of the bones or tell me all of the bones that are there. That's a little much for an introductory lab for this. You can just tell me that, you know, there are hand bones present, there are feet bone present. You can get more specific if you want to, but it's not required. And then you can include some notes. So whether it is complete, whether it looks like it's damaged or missing some, some elements, you can tell me with the vertebrae which types of vertebrae they are. You can also tell me any kind of miscellaneous stuff. So if there's like nails included or other random bone fragments or sesamoid bones. Then you will do your age estimation. So we'll start out by saying that the overall skeletal age estimate of the skull of case blah 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 is that of a skeletally mature adult. Your guys' will be a mature adult, so you don't need to change anything about this first section. Here where we have these bolded sections though, you need to include which suture sections had complete, partial, greater than 50%, partial less than 50%, and then open scores. So be specific about the suture names and how you scored them. Then your resulting mean score needs to be included for each of these scores, so the vault and the lateral anterior scores. And then say that they are consistent with an estimated skeletal range of whatever range that you found through this chart. And then you will do your estimation of sex. Do not just tell me that this scored as a 3, because that doesn't mean much to anybody that is reading your case report. Because remember, a lot of times these are going to police officers and other law enforcement agencies that are not doing these techniques themselves or don't even really know much about these techniques. So just saying that they scored a 3 isn't helpful. You need to describe the traits. So if you're pretty confident that your individual is a female, then you want to say that, the skull is characterized by subtle to moderate markings of gracility. If it is more commonly you think it's going to be a male, then you would say that it is categorized by settled to moderate markings of robusticity. And then you're going to mention all of the things that you observed. So if they had sharper looking eye orbitals, your superior orbital margins, or more blunt superior orbital margins, you're going to talk about how far the glabella projected. So whether that was a more subtle projection, more moderate projection, or a more kind of obvious or extreme projection. You guys don't need to talk about temporal lines. That's a little bit advanced. You can talk about the occipital protuberance. That is really just your nuchal crest here. So if it stuck out further, then you would say that there was a much more robust occipital protuberance or nuchal crest. You will talk about your mental eminence or mandibular symphysis, as it's sometimes called. So if it sticks out more or is more obvious, then you would say that it is more robust looking. As well as your glabella, if it projects more, then you would say it's more robust. But you need to describe all of those to kind of argue that your sex estimation is correct based off of these traits. Now, for the case that I was working on whenever I created this kind of mock case report for you guys to follow, it was an older individual, so I did have to include that this person had some more masculine features, but that they were more likely due to the older age of the individual. And then you want to end it by saying very plainly that all of your observations are consistent with a skeletal estimation of that of a likely, probable female or male, or that because observations are so inconsistent that a skeletal estimation of sex cannot be definitively made. You also do need to include your sources. That way people know which techniques you are actually using and basing your estimation on. Now, of course, this is going to be a harder lab for you guys. So if you guys have further questions, let me know. We can work on them kind of together. But this is also a participation lab because I don't have the time to actually work with you guys slowly on this so that you can kind of learn these techniques individually and see all of that happen in person. I'm not going to grade these based off of whether your estimations are correct for the remains or not. That is going to be scored based off of you answering all of the questions and filling out this mock case report in the appropriate format, which is the format that is given to you with this example case report. As well as that I, can tell that you guys put a little bit of work into this and that you are justifying your estimation of age and sex with sections of the bone, so with your observations. But if you guys do all of that, you will get full points for this, even if your final estimation is incorrect. Now, I'm not going to click on it, again, because of the ethical concerns, but the forensic materials, so the photos that you need to see, as well as a couple other instructions, are right here in the additional resources and activities folder. Do not share these with anybody. This means showing them to friends in person. This means saving them on any kind of device or sharing them on any kind of social media. Don't text them to anybody. Don't save them to your personal laptop to look at later because you think that they are cool. Nothing like that. They are to stay only in this Blackboard class and used only for this lab because it is an ethical issue. If I find out that anybody has shared these or saved these materials, you will not only fail this assignment, you will, I'm very serious, you will get a 0 for this assignment, but you will likely fail the entire class and have to talk to somebody at the university for ethical issues. This might sound kind of extreme because this is a teaching collection, so they are bodies that have been donated, but these are still real human remains that belong to a real person that had real feelings and real emotions and a real life, and they still deserve that respect and that privacy to not just be blasted on social media or shared with individuals that they were not intended to whenever they agreed to donate their body to science. So just please be aware of this, be respectful of this. But that is all I have for you guys today. So like I said, let me know if you have any questions. And I will see you guys next time.